power of 2 and the power of 8. Can you find more examples where you have the same number in multiple power families? That's going to come into play when we start changing the base. Does anyone see this number 4 appears in 2 and 4, right? So 4 appears in 2 and 4. What's another example of something that appeared twice? Yep, 81 appears in 3 and 9. So that means we could represent 81 as 3 to the 4th, right? Or as 9 squared. Just like 4, that's either 2 squared or 4 to the first power. So you end up seeing that you can change bases. And we're going to use that as a strategy when we start solving exponential functions and equations. This is an important fact that we'll emphasize a couple times. What is anything raised to 0 power? It's always 1. And if you notice, I like pointing this out. How did we get these numbers? We multiplied by 2, multiplied by 2, multiplied by 2. If I want to go backwards in the table, what do I have to do? Divide by 2. Divide by 2. Doesn't dividing by 2 give me 1? And then dividing by 2 gives me a half, right? Or multiplying by a half. So it actually fits as a 1 in every single row, right? 3 times 2 is 9, 3 times 3 is 9, 9 times 3 is 27. But if you divide by 3, divide by 3, dividing by 3 holds the pattern. If we just made this whole row zeros, it wouldn't work for the pattern to go all the way across the table. So that's why mathematically they define anything to the 0 power is 1. And if you ever forget, just check it on the calculator. Because if I plug in 8 raised to the 0 power, like I get 1 on the calculator. So when in doubt, you could just check it. Mathematically, it makes sense, and that's the rule. What did you notice about all the negative powers? I kind of already said that, but it is the reciprocal. And we're going to talk about negative exponents a lot because I feel like that's something students are not familiar with. But if you take the number, 1/4 and you raise it to the negative second power, you take the reciprocal, that's what the negative does, and just square it. So the answer is going to be 16. So 1/4 to the negative second power. That's going to be something that's a little bit challenging this unit that we'll keep talking about negative exponents. So on this page, did you notice something about the powers of 5? Does it end in 25 or just 5? Oh, I never noticed that actually. I always thought they just ended in 5. So yeah, either the 5, so the ones place is a 5, right? So if you're trying to think about, I wonder if the number 725 is in the power of 5 family. It's not, but you could check because it ends in a 5. What did you notice about powers of 10? We should know that the ones place is always a 0, right? Powers of 10 are always 0. All right, and then I just wanted you to use the table to think, okay, what number cubed gave me 27? So x is just 3. What number to the 8th was 264? So you look back at the table, you find 264, and what number is it? You see what I'm saying? So you find 264. I can't show you, but you find 264 in the table, and it must be 2 to the 8th because it's in the power of 2 line, right? So that's how you use your table of powers. So 2 to the 8th is 264. And what number to the negative 4th power was 1/16? That was also in the power of 2, right? So using your table, really, I'm not going to ask you a lot of the perfect cubes, but you should know like 27, 64, 125. You should be able to do any power of 10, right? 10 to the 5th is just add 5 zeros. But some of these lower numbers on the table, you should know that's 2 to the 3rd or 2 to the 4th because we're going to be using this kind of circled area a lot. So recognizing your powers. So when we come back from lunch, we'll kind of